my opinion, this one is one of the most advanced and hard to understand topics that probably JavaScript contains. That's why outside of the lecture, I will provide a lot of links, a lot of self-study materials with which you can kind of enforce your knowledge about in-depth organizing of asynchronous functions, asynchronous actions. And today on this lecture, we are going to go through all the basic materials, practical examples, and let's begin with set timeout, set interval, because it's the most relatively simple out of everything in the asynchronous programming, and it's easy to understand, and that's probably will be the first thing you will kind of get in touch while programming something asynchronously. So in Web API, set interval is a function which is in the browser actually. So we have Web API, and that Web API contains several methods. That's not a pure JavaScript, but Node.js contains it too. So let's get in touch with the syntaxes, and what set timeout is allowing us to do is to do some action after the certain period of time. So the syntax is like this. We are just writing set timeout, and then we have to pass two arguments, two mandatory arguments, I would say. The first one is a callback. So basically what we are doing here, we are passing an arrow function, but it would be okay if we would use just a regular function like this. But since we are mostly writing in ECMAScript 6 version, it's always better to keep it simple and syntactically and visually better to understand. So we have set timeout, which accepts the callback function, and then we are just writing the action we want to perform. For example, it can be console.log, which will say that I am an async function. And the second argument is actually the period of time after which the function will be executed. So let's give it, note that the second argument is passed in milliseconds. It's not regular seconds. So if I want it to be executed in 3 seconds, I'll pass 3000. And if I run this, it will wait for 3 seconds. And then I will just get my result. Please note that here I can just pass a regular curly brackets and do all the other calculations. For example, let me fix that up. For example, I can declare a constant. For example, it will be test. I can assign some 12 to it. I can say that test equals test plus 5. So what I want to say is that it's just irregular functions which are passed as the first argument. As I said in the previous lecture, they are called callbacks, and the second argument is, as I said, the timeout. So in except of the set timeout, we have set interval here. So set interval is almost the same, but it is going to console.log something that we passed one after time, time after time. So for example, if I pass here a function which console.logs again, and then I pass some kind of 1 second here, and then I just run this. I'm about to hear again and again, time after time. So logically, there should be a way to stop everything, right? That's why both set interval and set timeout by themselves are returning the ID. To show that much more clearly, I can go here and say that, or just go to the console straightforwardly. And if I say const set timeout or set interval to be more precise, the actual value which is returned is so it will be the ID. So after we are going to so if I say const id, set interval by itself will return me a number. In this case, it will be either 1 or 2. Well, it like goes like straightforwardly. If I say 2 set intervals, it will give me like 2, and if I just declare 1, it will give me 1. So what I want to assume with that is that setImInd by default, like not its callback, but the function itself is returning the unique ID of the set interval in our code. That lets us to clear interval. So for example, if I have set interval here and I will just clear the interval, I have to pass the ID number. Please always keep in mind to follow up the suggestions of the Visual Studio Code, because I know that's the most popular code editor, and it's great that it's just say that we should pass a number, and a number is an ID. If you are not intent to stop the execution of the callback function, you can just remove this part, because you don't really need an ID. But in case of using set interval, it's pretty logical that we will always want to stop it somewhere, because first of all, I can't really remember an action which should be executed time after time. Maybe if you are programming some kind of goofy clocks or something like that. But in general, please keep in mind that set interval is a bad approach. So you better to use set timeout one after time, so like by recursion or something like that, then set interval, because that's pretty hard to explain, because that gets its roots by under the hood of JavaScript. But the thing is that set interval is including in its time the calculations to perform operation provided in callback. So what I want to say is that if we would have some heavy operations, we wouldn't be guaranteed that the set interval would execute the function in like 1 second, because in case of set interval, the calculation time of callback, if I have some, I don't know, mathematical statement here, which is going to take a lot of resources, it will be taken out of this time, which means that it's not the best approach. We won't get the right time here. And both of these methods are unique for Web API, and they are both asynchronous. What does that mean? That means that if we would console.log something under it, and console.log is just regular synchronous function, right? We've already done that. And I want to kind of point out, so what is synchronous and asynchronous functions? Synchronous ones is the statements which are executed after the previous statement was executed. So if I have something like let a equals to 5 and then console.log a, that will mean that it's just synchronous, because I declare the variable and then I console.log that variable. There is nothing containing time. But at the other hand, we have set interval. And right now, if I start, let's just do it with set timeout, because that's a better approach in general. So while this set timeout will be executed, firstly, I will get 5 when I console.log here. So that means that this console.log will be executed firstly, because of course we all know that these statements should be executed after some period of time, and JavaScript denies the opportunity to stop and just wait. It's not working like that. It's just determining if we have any other synchronous or just regular code following that asynchronous one. That will mean that they will be just executed, because JavaScript it's a matter of optimization. If I'm waiting for the response from the server, for example, which is the one of the popular use cases of asynchronous functions, because I'm so requesting something from a server and I'm not exactly sure when it will be delivered to me, because that request has to be processed. The backend should send me some data and then I should catch that data. I'm not sure where I will get it. And in that case, JavaScript don't want to just sit and wait for the server to respond, and it moves to the next operations. That's what set timeout is about. And previously, like at the beginning of the JavaScript, there was no asynchronous things because JavaScript was not intended to make a calls, do something change in certain period of time, because it was mostly to so JavaScript was basically used to make green button blue, and that was its purpose. And after that, the first decision. So the thing here is that sometimes I need something to do according to the data that might be asynchronous. And that is the thing of when the JavaScript developers created callbacks. So let's see what do we have here. We have a regular function which accepts a src parameter. Src is just a path. And here I'm communicating with a document object model. So I have script, just a variable, and I created an element which is script. And then I just gave it an attribute of src, and it's equal to src. So right here, I'm passing the path to some kind of a script file, and I want that script file to be loaded inside of the script file. So I'm appending everything in the HTML file, just like we do with the DOM. Um, the problem is that now that the other script file I loaded may have some function. So let's imagine that this script file contains a function, like it's just a normal file placed somewhere in JavaScript folder, and it's just script.js. And I loaded it inside of the HTML document. So I have function, which is called new function there. And after I passed script inside of the document head, I should be able to call that function, because now it's available for my script as well. So if it's there and if it's loaded, I should be able to call it. But no, I won't get it, because new function doesn't exist. Why? Because script creation and script creation is an asynchronous code. That means that if we have our script here, that means that it won't be moved to the HTML document immediately. It will take some time to proceed, right, to create it. And while it's proceeding, JavaScript is simply going to the next lines. It stops executing this function until it is created. And it comes here. I'm loading the script, and it's not fully loaded because script is not uploaded yet. And then I'm trying to call new function. New function starts executed right before document create element script is worked. So we don't have new function because we haven't appended everything. We are just waiting for the script. It's a matter of millisecond, but it can easily happen because if I execute this code, I mean, it won't work anyway because we don't have HTML element, we don't have a script file, but theoretically, it won't work in any case because this statement is waiting for to be proceeded, and while it's waiting, it came to the new line, and that new line is dependent on when this line will be created. So that it's just doesn't exist, and there should be a way to make them kind of go, like, wait for each other. And that way, the first thing which comes to the mind is the callbacks. So callback is the first thing of when you think about asynchronous code. And the idea here is that we are creating our script here, we are setting its source, and then we are saying that script onload, which is an event. And as you know, all the events are asynchronous because we don't exactly are sure, for example, when the user will click a button, but the event should be there. It should be loading, and after it will accept some data, after it will be executed, we will be able to track the event itself. Because, for example, we don't want our page to be freezed while before user clicks that button, because as I said, won't be executed in any case because it will wait for each other. So um, Here I added onload, which is an event, and when it's loaded, when script is fully functional, I want to execute a callback. So it accepts an anonymous function and callback is executed. And what am I doing here? I'm calling the load script function. I'm passing the script just like I did it here. And then the second argument is the callback function, which calls the new function. That makes us to be sure that this new function will be called only after the script will be loaded. And this is the first decision which can we make to kind of make everything work. Also, when the thing comes to asynchronous, you can't assume that this operation will always give me a successful response, right? Because that script, this operation might be, for example, source might be broken, and so what are we doing? It won't be found, so we have to we can't deal the case of success like we deal the case of the error, right? Because usually we don't want anything to fall out of the console. We don't want user to see any error, and at worst we don't want our code to stop executing after it saw any error there. So what we can do here is provide two events here, which is script on load and script on error. So this pattern is actually something interesting, and you won't see this nowadays because we moved to more advanced methods of handling asynchronous code. But back then, that was a pattern of reserved error argument. So what does that mean? We have a load script function just like we did have it, and the first argument is always error. So here I was passing a empty function, and here I'm passing two functions, two arguments. First one is an error, and the second one is like any data I want to take from this upper function. So it might be not script, it might be something else, but the case here is that we are just checking if error is true. When we are just handling our error, for example, we are just saying console.log error message or something like that. And if it's successfully loaded, I want to like alert and say something like successfully loaded. So the thing is, or I can say something like backtick a script. So the thing is that I want to deal with them differently. Here I do create a script like I did before, but the thing I added is on error. So what am I doing here? On load, I'm having a callback with false first argument. So that exactly is a pattern of reserved first error argument. So I have an error here, which is passed as a callback. And if it exists, that means that it's an error and it will stop executing. But when I'm passing null, this check will give me false, which means that the script is successfully loaded. And script is just the second argument, and I'm just printing script. Yes, and that means that it's successfully loaded and we successfully dealt with error scenario. Because in any project you will work on in the future, error scenarios should be handled, because otherwise user will see the information he is not supposed to see. It's either console error messages which are falling. It might be stopping of execution code in general, and that things should be prevented. That's why we are writing else block here and if block here. If our error exists, we are just console.logging that message, but that might be pretty complex logic. For example, I would try to send the Ajax request to a server, or like repeat the request or something like that. But this approach has a lot of minuses. The first thing is that it can really became hard to understand. Why? Because what if I have 5 script files and I want to deal them one after each other. So I want to load first script. When it's fully loaded, I want to load the second script, then the third one, and the fourth one, and the fifth one. And that is called a callback hell. So what is happening here? I'm loading first script.js, passing a function which has error and script. I'm checking if that step contained error. I'm handling that error. Of course, this function does not exist. It's just theoretical. So if error exists, I'm handling that error. If not, I'm loading the second script. And that is already the well, not pleasing for the eye to say like it's the second script. It also has error and script, and if error appears, we are handling it. Then the third layer appears. What if I have 10 scripts to load? That will make my code look like a mess. That's why there was a need to introduce some new feature to kind of simplify that process, and they did introduce it. Now no one really uses callback when it comes to some then it not comes to some simple logic. If everything is straightforward, yes, you can use it. But if something gets complicated, we are moving to the promises. And promise is a bit hard to understand at first, but it's a matter of time. And after that, you will feel much more comfortable of writing them instead of callbacks. So basically, promise is an absolutely new instance. So let's create a variable, which will be new promise. That's how it's created, like that's the only syntax, and it accepts a callback again, which has basically two arguments. It's resolve and reject. So it's basically two cases. It's either resolved or rejected. Of course, you can name it differently, for example, res and reg. It's actually pretty much popular code style, but I will write just resolve and reject. And it's accepting a regular function, so it's a callback, just basic callback. And here I can just say resolve. So basically, what am I doing here? I'm resolving a promise. And what is promise? Promise is instance which is in three states. So it's either pending. Pending, that means that it's still in progress of waiting for something. It's not still fulfilled. And the other is resolved and rejected. So basically, it's either resolved or rejected, or it doesn't know yet. That might be the first or the second, but in the future. Right now, we have no idea how it will be fulfilled. So basically, if I console.log promise now, that will give me promise. Let's do this. So I'm having promise of undefined. So it's a promise. It's not resolved or rejected. It shouldn't be done like that. Um, why? Because when we are dealing with promises, we need to have then. So what is then? Let's imagine we have something asynchronous here. Let's just set timeout. It will accept an argument like like we did before, and we have resolve here. Right now, I'm kind of imitating the server request. For example, here, that might be some logic which takes the data from the server, and after the data is resolved, I want us to get data was successfully successfully fetched. What is this? Right now, I'm having just resolve, but there can be cases where reject is more useful. So let's imagine I want to do something with that data. If I just console.log promise, that would give me the status of the promise. So it's not neither fulfilled, neither rejected. It's just a promise in the state of waiting, because it couldn't be otherwise. Promise is something that doesn't gives you something instantly. You have to wait for it. And if I just call promise here, it will make it confused because it will show you the status and not the actual data, which is not resolved yet. That's why you have to wait for it. The syntax of waiting for it is just promise then. Then is a thing which waits for the resolve to be resolved. So it's waiting for this function to be executed. And only after that, the function passed to then is like executed rightly. It accepts the parameter of 1 or 2 arguments. It just doesn't really matter, but it's basically one, typically one. And it's basically called result. In our case, the result will be this message, because that's the only data we pass to the resolve. So basically then catches this function, gets its data, and does with that data everything you want it to do. So right now, if I just do this, data was successfully fetched, but I want to give it some time. So let's imagine that we are making some asynchronous call and the data is successful, and we are just doing it like this. Data was successfully fetched, and we got that only after we received the resolve with its data. If I just say console.log data promise, we won't get anything because promise is pending. It's waiting for the response. It's like the 1 second haven't passed yet, and even if it would, it's still asynchronous. We wouldn't see the result here because we have to catch the data from the promise, not the promise itself. That's why we have to use thens. Also note that thens are chainable. So remember our callback hell when we were calling a script one after another and we had the triangle thing. We can really resolve that with this thing. So for example, I have a result and here I can create a new promise which would have its then, but let's like stick to something pretty simple. I can, for example, pass here s, and here I can just do a result split, which will just split the string we have here apart. And then after that, I can add another then, which will have result as well. And right now I can already console.log the result. Of course, it's not that useful because the result.split is a synchronous code, and I can simply return something and like do it synchronously. But the thing here is that after you get some data from the server, you might want to do some asynchronous thing with it. For example, send it to another endpoint of the server or send it somewhere or render for example, you are getting the coordinates from the server and you want to pass that coordinates to the map, and map has to take some time while giving you the image. And that's why in this then I can still pass an asynchronous code. But right now the main point is that thens of the promise are chainable, so I can add how many I want. Just note that the result of the next then is the return from the previous one. So for example, if I say result here and do console.log result, that will give me undefined. Why? Because console.log result returns undefined. Because of course it console.logs the result, but it returns undefined here. And that's why we can't really proceed with this approach. But yes, it's really simple to do something like this. For example, console.log the result, and then we are straightforwardly returning the result ourselves. In this case, it will just work fine, and we will be able to get our splitted document twice. Yes, that's what we get. So it's about the resolve, but also we can have reject. What does reject mean? So basically, if I would have some real data from the server coming, sometimes it will come with an error. And in that case, we are doing something like if like we should have call here, but I can't like show it practically. So I will just say reject. Reject usually gives us an error. So let's imitate that. We'll pass a new error here and fetching failed on the server. If I do everything if I leave everything like it is now, we are getting an error. As I said, errors should be catched because we are not intent to break user experience. We don't want them to fall to the console, and that's why we have another method which is catch here. So catch basically accepts an argument just like rejects do. For example, resolved accepts one argument which was successful fetching, and this one accepts an error. So here I'm catching it. I'm saying like error. Here I'm just console.logging that error. We will get an error, but different one. So the error is the error I created, and if I just say error message here, I will just say that fetching failed on the server. So basically, I tried to make the error. For example, here, instead of showing that error in the console, I might want to send the error message to the analytics to kind of know what happened for some user, or that might redirect the user to a different page. That's really like big scenarios that may happen, but in any case, everything is better than having a unhandled error scenario. And also there is one more method which Promise has, and it's finally. So finally, basically something which so doesn't matter if we had something. So basically, if it's success, finally will work anyway. If it's error, it will work anyway. It's really useful because you probably haven't learned yet, but you might have a socket and the socket is closed, and after I get the right result or bad result, I should be able to do some action afterwards. So when everything else is done, you are running finally to kind of summarize the calls you were making. And it's pretty useful to chain it like that. Also, what you can do is to do a lot of catches here. It is possible, it's not the best practice, but for example, this catch would catch the error on this line and kind of not give you the one single error message, but like it would say that, for example, if catch breaks here, that means that the error was either on this line or in the reject itself. If it's somewhere here, if it made to come till here, that would make that the catch happened somewhere here. It's yet not the best practice to do so. But promises is, even though thens are actively replaced with the better experience, so thens are also in newer projects, in modern projects, are rarely used, but they are used. And you can simply like, you will probably came across of using them, and it's pretty much necessary topic to know. And also that might come to the interviews you will be having in the future, because that's pretty much popular topic to ask about. So now we are moving to the next syntax of how we can handle everything, and that is async await, which is really a relief because even thens are hard to understand, but awaits are not. So basically we have the same promise here. And set timeout, it's just like I wrote, we have a promise. We have a regular promise which accepts the resolve and reject, and it's returning us a set timeout, which might be the call to the server. And after that, it's just resolved. I'm just saying that it will be fine. Of course, that's pretty poor scenario, but okay. So we have res, and now, as I said, if I just cancel that log promise, it will give me pending because nothing really happened here. And since nothing really happened, I have to use thence. But there is much more clear syntax. It's under the hood, it's completely different, but here I can just say that const data from the server equals to await promise. Await basically waits for the promise to be executed, and then it's just assigning it here. But there is one catch. If we are using await, we have to have it in asynchronous function. So this is the regular function. And if we execute it like this, we will certainly get an error. Why? Because fetching failed of the server. Let me catch that out. It's because file. Yeah, so basically we are getting the server and we are getting an error that await is only valid in a synchronous function. To make the function asynchronous, it's simple enough to just write async here. So just remember that await is used only in the cases when it's placed in the asynchronous function. Also keep in mind that that might be an error function as well. So I can replace that with the arrow one, const arrow async function equals to async. It's a regular syntax we are using like pretty much every day. And here I can say that const data from the server equals to await promise. As simple as that. So basically await is another form of saying then. And basically the await will be the data which comes from the resolve. So everything is here will be passed it to the data from the server. And that's really, really noticeable when we are writing REST, which, for example, returns a promise. Imagine having promise here. It's pretty, I don't know, complicated scenario, but you might have something that is asynchronous in two layers. So resolve will also return you a promise. And in that case, we would have to write something like promise, then result. It would be equal to result, and then another then, which would get the result here, and only after, like, only after, like, catch the result itself. But right now, then we have the await. We can say that const first layer promise would equal to await promise, and then the second layer promise would be await first layer promise, and just as simple as this. But of course it's not really valid example, but it works. So just keep in mind that we should have a synchronous function, which let's call it just as async function. It's really like not mandatory to have any arguments here because equals to await promise, and it will give us the everything which is passed in the result, so success. So right now we are having just the result. In case of promises, we had catch with whom we could catch our errors. But here we can't really do that. And if we want to handle the errors here, we can do something like this. We still need to have a synchronous function, but inside of it, we will have try. Try is something which handles the exception. So it tries to do the first line. I'm not sure if you had something like this before this lecture, if it was in your study materials, but basically what this scenario does, it tries to execute everything in the try block. And if some error appears, it will just simply it will just simply do the action which is passed here. So, for example, in this case, let me try to charge my laptops. In this case, we are trying to get the data from the promise, which will be just the same like we did before. So we are just writing const data from the server, and it is equal to await promise. But if the error appears, we are just saying that console.log error message. And it will work. If we run this code, it will just wait. Well, we can console.log data from the server as well. So it would be used anywhere, and this is much more beautiful way to deal with promises or any asynchronous code. For example, in the future, you will probably have a need to get something from a server with fetch API. As you may know, fetch returns true promises. So for example, if I fetch some URL, um, it will return a promise, which is returning a promise. So we will have to await an information from it twice. Also, keep in mind that await makes the code stop until the promise will be fulfilled. So for example, if my promise will be resolved in 1 second, the await will wait for it actually before going to the console.log. That is the unique ability of something called generators. So it's generators basically going under the hood. And what are the generators in 2 words? It's absolutely not necessary to know for this moment. But what generators are, there is a pattern in any language run to completion, right? So when we are creating a function, just any regular function, right? It won't stop executing it if I call it, for example. So if I call it, it will be inside. So the code interpreter will be inside of that function before it runs everything inside. So until that moment, it won't come up, it won't come outside this function. But generators are the function which can stop, pause executing of the function and return to them a bit later. It's not mandatory to know for now. I will probably provide the study materials on that as well in the Discord chat. But right now, just let's focus on the await, which is the nice syntaxes of dealing with promises. And the last thing I wanted to talk about today is how everything internally works. So there is a lot of weird things going around the synchronous code, and let's kind of try to figure out what is happening. So that is probably the worst visualization you have ever seen, but it works. So let's just don't touch it and say that we have an event loop. Event loop is a thing. It's basically an ability for us to deal with asynchronous code. So event loop is some technology inside of JavaScript, which determines where and when the code should be run. So basically it determines if it should be now, if we should wait, if we should pass it to somewhere else, and like does the calculations. And also we have tabs here. We have a call stack, we have a web API, we have a microtask and macro task queue. That's everything you should know about asynchronous code. But before that, let's just focus on the call stack. If you ever got the, oh, we have it here. So basically this is the call stack. So for example, the first thing ever run in our code was main module. Then it was execute user's entry point, then function model load. And so it's kind of layer of how our code was run. And at the top of it, we see the most recent thing. Await is only valid in inside function. So this is basically the call stack. What it means, it's the sequence of compiler executing our code. So let's say it's regular synchronous code. There is no set timeouts or promises here. And the first thing which is executed is greeting. So this function, let me just explain the code. We have say, which accepts the word, and console.logs that word. And we have ask. Ask just simply says, so the say is the function it calls with word how are you, and the function greeting is say with hello. So basically the first thing which is executed is greeting. So when compiler sees the first thing which is executed, it copies it, well, puts it in the call stack. That means that the greeting should be immediately executed. What is stack? If some of you doesn't know, greeting is, so call stack is, so basically stacks are something which always, so if we want to place something, we are um, placing that at the top of it, and if we want to get something, we are getting it from the top of it. It's like array method of I don't know, push and pop. So we are pushing at the end of the array and we are popping it from the end of the array. That's how it basically works. So when we come to the greeting, so we are now here. Greeting is being executed. The first thing we see is say. So our executor knows that before going to ask, we have to go to the say. That's why the say is also passed to the call stack as the second thing. We are following that say, and say brings us here. And the last thing in the chain is just console.logging. So console.log word, the word is being console.log to the console. So it's finished. It has no more places to go. We don't have any additional code here. It finished line. That's why from the top of the call stack, console.log is removed. Then it goes to the say. So say is not needed anymore, right? Because we are going to the ask. Say is removed also. And then ask is appearing, so it takes the next thing should be executed. Ask come here, so then we are following ask, we are going to the say, which is how are you. It's also taken from here and pasted in the call stack. And then when we are following say, we are going back to the console.log, and it is placed at the bottom, at the top of it. When the how are you is passed as a word in the console.log, it's like already in the console, so that means that the function finished its execution, and now one by one, everything is popping out of the call stack. So it comes back to the greeting, and it turns out that the ask was the last thing which should be done in the greeting. So greeting is passed from here as well. That's how basically call stack works. It just passes things here and kind of determines the order of their execution. Let's go to the more complex example. So we have three functions here. Two of them is synchronous. Second, it just console.log second. Third, console.log third. And the first, console.logs first, but in the set timeout. Notice that here the parameter is 0, so that logically speaking, that means that first should be console.logged at first because it's 0 seconds. That means that it shouldn't have to wait and it should be first. But if we run this with this piece of code, we will get second first, then third, and then first, because we just have set timeout here. And let's kind of try to figure out why is that happening. So let's go here. So this is the function declaration that has nothing with the call stack, and here we can see the execution of the function. So it sees the first at first because it's the first line, and it passes it here. So in our call stack, first is already passed. That brings us here in the first function. It says that we have set timeout here. So it says that timeout is the next thing it should do because that's the only thing in the first. So set timeout should be executed, but call stack can't determine where it should be run. So there is a 0, but call stack is just an array. It's kind of an array. So it has to be passed somewhere. As I said, set timeout and set interval is a web API place. So it's managed by web API. So set timeout gets cleared from here, and the console.log first is passed to the web API. Web API is basically the thing which created the set timeout and which is determining where to run our code. So it just counts the second and waiting for them to be a 0 again to push it back to the call stack. But Web API has no ability to push something back to the call stack. That's why it should be placed somewhere else when the time like goes to the 0. And that's why this statement is passed from here to the macro task queue. So every asynchronous action we will have are going to the macro task queue. So it's already 0. It should be console.logged already because it has 0 here. Web API determined that it's over, the waiting time is over and pass that to the macro task. But the thing is that macro task works in the way where it should wait for all other synchronous thing to be executed. That's why first is removed from here because it's not needed anymore, because there is nothing except set timeout to be run. And here comes the second. So the second is passed here. We are following the second. We don't see anything asynchronous here. That's why the second console.log appears. When second is appeared already in the console, console.log is clearing from here and the second is gone as well. And then comes the third. Third is passed here. After third, we see console.log here. And the third is also taken to the console. It's removed. And only after we have nothing left here, first is executed, second is executed, third is executed, it comes the place for the console.log to join the game. And only after everything else is dealt with, console.log is passed straight forward to the call stack, where it just console.log first. That's why we are getting a first, second, then third, and then first, because set timeout is being messed around. First it is in Web API, which determines where it should be run, and then it is passed to the macro task queue and it's waiting for the queue to be cleared of all asynchronous actions. And finally it's moved to the call stack, and after its execution it's finally removed. And this logic is managed by the event loop itself. That's why it's the most kind of complex thing in the JavaScript language. Is pretty hard to understand. And we are not stopping there. I have something even harder to understand. So we have two functions here. And the first function accepts set timeout, just like we had it here, but without curly brackets. It's just the statement, but let's say it will be like we already did for consistency. For example, say timeout. It will have a argument, just an anonymous function, which will go to the console.log. It will console.log, I don't know, first. And that's basically all. So the first is a set timeout, and the second is a function which console.log something, but also it returns new promise, and that new promise has then. So we already talked about then, and that is really interesting how it is determined. So first, of course, goes first. So when we are going to the call stack, the first thing to appear there should be first because it was the first function which was called. Let's pass it. And after the call stack followed along the line, it saw the set timeout, okay? And when it saw it, set timeout is also passed here. But as I said, set timeout is dealt differently. That's why it's moved from here and it's passed it here in Web API, but not the set timeout, but it's callback. So in Web API, we passed console.log. That's how the JavaScript interprets it. Web API, in its on behalf of being the counter, it waits for the seconds to go by. For example, let's say 1 second. And why it goes by when the console.log thing is over, then no second is left. It's just taken from here and took to the macro task place. where it should wait for the other actions to be executed. First is popped out from here because there's nothing more to have in first, and there comes the second function. Second function is put it here as well, and it follows the function right here. So the first line is console.log, which is pretty synchronous. So why shouldn't it be executed? We came here, notice that yet nothing came to the console. So after console.log second appears here, it will actually be console.log. So the second goes first. When the second is already in the console, it is removed from the call stack, but second has a lot of things to do, right? Because in second we have the whole promise. Notice that this is the example which you may came across on the higher interviews, and it will be structured like this: what should come first, and what should come second, and what third, and you will kind of get pretty much get used to this syntax of returning new promise, even though it seems pretty complicated. If you write like 3, 5, 25 promises, you will kind of understand how it works. So this particular promise is returning resolve and reject. And the first is resolve. Please don't think that promise, if it's promise, it's always asynchronous. Everything inside it's just a function, regular function, and the rest is the next thing to be executed. It is executed, so it does everything it should do, but we have then, and that is really interesting thing because we have call stack, which we saw, we have web API, which counts down, we have macro task queue, which takes care of asynchronous actions, and we have microtask queue, which we haven't touched yet. So then is the only thing, well, promise objects, finally, then, and catch are the only things which may go to the microtask queue. That means that after the res is resolved, which means that then should be run. So JavaScript is skipping this part and goes to the then. So the next thing to log is the fourth, which will come to the macro task queue. So everything inside of the res is executed as well. So it's okay now. So rest can rest for this moment. And the next thing to be console.log is this, because we kind of skipped that part. First was this console.log, then we could, when we resolved the promise, then came in, and then is already here. And now we are going with third argument to be console.log. Since it's already in the second, we can just pass it here, and after it is completed, it's just removed from here for good. Then we have finished with executing the second because there is nothing left. Everything is dealt with. That's why it's removed. And now we have only two items to take care of in microtask and microtask queue. And just remember that microtask is more important. So when we see then, we mean that it is executed sequentially, which means that the microtask queue should always be executed first. So remember it like this: we cannot take any macrotask item before all microtask queue are in the call stack. So if we have 3, 4, 5 console.logs here in microtask queue, they all would be moved to the call stack before this console.log first appeared. So basically right now we are taking this console.log, we are passing it here, and after it is executed and moved to the console, we are taking the last macrotask queue, which was first, which is strange, and that first comes last. So the sequential will be like this. Second was first, third was second, because, well, yes, it was third after, then it was fourth, and then it was five. Oh, but the only thing forgot to mention is that after the first and second, we have console.log first, which means that it would basically be executed before these guys here. So if we have something synchronous, I said that microtask queue can't, macro task queue can't can be moved to the call stack before every synchronous items are accepted. That's why it will be first console.log fifth, it will be logged, then it would be fourth, and then it would be first. So this is the sequence. Second, third, fifth, fourth, and then first. So that's basically how the event loop works. I strongly advise you to read a lot of in-depth topics about this particular technique, because there is some additional layers of how it can operate, and it's pretty hard to understand without strong visualization support. And I think some kind of a in-depth materials would kind of help to create a more abstract or more in-depth picture of what is happening here and why do things work like they work. Also, out of all of this topic, I would advise you to, okay, you can like no, but skip callbacks because they are not used on the everyday basis, and just focus on promises because it's the most useful thing out there when it comes to asynchronous code. Even if you won't need to call then, since you have your async await, and you can get your data with await much more simpler when you can do it with thens. You still should know it because it's probably one of the most, I don't know, used interview questions out there, and you will be asked a lot about it. So it's really a thing to stay focused on, and to kind of go in depth and understand how everything works under the hood. Now let's just head back to answering questions. Overflow, call stack overflow, it has nothing really about the asynchronous code. It's just internal thing, and you probably won't ever deal with it. So it's not because we moved something asynchronous there, it's just because there is no time. So basically, all languages are single threaded, and that is so not all languages, but JavaScript is. That's why here we have sequential, they can't work. So that's why the event loop is created, to make everything go line by line, because JavaScript cannot deal with certain things at the same time. And that is the single threadity of the JavaScript core, JavaScript asynchronous actions, that causes the call stack to overflow. Do you have any particular questions of async await? Oh, by the way, I think I have a topic about Stack Overflowing. I will provide it to you. It is not in the scope of this particular lecture, and I don't think you will kind of see it in this course, but it will be nice if you will get to know it just like lightweightedly. And as I said, it can, all the asynchronous thing can be actually be in one single lecture. It's pretty complicated topic to get away with, and that's why there will be probably a lot of study materials, and you can simply learn it out of there. The principles are, well, same. The most hard thing about asynchronous code is how the event loop works. So before observables, it's probably much better to focus only on only on event loop to kind of know why everything is executed in the scenario they are executed, because that's the most confusing thing. Any more questions? It's really a complex topic, so okay, so if we don't have any questions at this moment, you can always reach out to me in Discord or Teams if you have some coding related questions about theoretical or practical one, and we can start to finishing off this meeting. Have a great day, everyone. Thank you. Bye. Have a great day.